Hello again, everyone. In this module, we are going to take a look at working with the OS, which is short for Operating System module, one of the many modules that are available by default in Python. This one allows us to navigate and work with a file system of the operating system that we're working with, along with sys, but this one is more complete. Let's go ahead and create a brand new Python 3 notebook. And I'm going to call this one 011 OS. 011 OS. Okay, to begin working, we want to go ahead and import it. So we import OS, and if we don't get an error message, it means that everything was just great. Let's take a look at what's available in this. I can do a print dir OS. You can see it returns a list of all kinds of methods and attributes that are available for us. So we're going to take a look at several of these right here. For instance, we'll take a look at get current working directory. Let's actually go ahead and do that. Let's do print the current working directory. So I'm not sure where I am right now. So I can say print os dot. Remember, whenever you press the dot, you can press the tab key, and Jupyter Notebook gives you these methods. So I want get current working directory, open close parentheses. And it tells me that I'm sitting under C:user student desktop Python. I know where I am. We can navigate by, if you're familiar with the command line navigation, we can navigate using OS. Let's go ahead and do some navigation. I can call the OS and to change directory, which is chdir, and go to the parent folder, which is designated with 2 dots /. This is also the case if you work with a command line before. So I'm in Python right now. By doing this, this should take me to the desktop. Let's go ahead and print the os.get current working directory after that's done. And you can see we are sitting in desktop. Of course, I can do this multiple times. If I were to do os.change directory // that's going to go up 2 levels. So currently being in desktop, that should take us to to student and then to users. Take a look. We can go the other way too by doing change directory, and I can basically, there is no shortcut here. You do have to put the directory name, so I need to go to student /desktop /python, like that, and then print the current working directory. You can see that I'm actually there. Okay, so it's fairly straightforward. If you're familiar with working with the command line, this should come to as second nature. Let's take a look and see what files and directories are in the current directory. I can do a print statement and call OS and do a list directory. Well, it tells me that I have all the programs that we've been creating over here. They're all showing up. A couple of hidden stuff is showing up too, and it shows a cache, which is a method over here, as you can see. Fairly straightforward. We can go ahead and actually create stuff here. Let's go ahead and create a folder. So there are 2 methods for doing this. I can do mkdir for make directory, which makes a directory or a folder. I can do make, and notice it's spelled out, make dirs, which creates all subdirectories also. Let me put this on a separate line because it's running off the screen. Okay, let's go ahead and do that. os.mkdir, let's say sample. Let's verify that. I'm going to go to my desktop Python, and there should be a folder here, sample. There it is. Good. Let's go ahead and do os.makeDirs, and I'm going to create a data folder, and then a pubs folder inside of that, a stuff folder inside of that, and my stuff inside of that. None of these exist, but let's go ahead and see if it does it. Let's go back over here, and I can see data was created, pubs was created, stuff was created, and my stuff was created. So everything was in fact created. Beautiful. We can also remove these. Let's go ahead and take a look at removing some of these things. I can do os.rmdir for remove directory, and I can call sample, and that should get rid of it. We can verify that, and it's gone. Now the problem is if you try to delete data, it's going to give you an error message. Again, this is consistent with operating systems. It's going to give you an error message because it has subfolders in it. So what we can do is we can go ahead and do it this way. I can say os.remove dirs, just like make, the remove is spelled out, and then type in the the entire path, stuff and my stuff. And by doing that, if I go back here, I can see that that entire hierarchy was removed. We can also use what are referred to as shell utilities. To use them, we do need to import them. So import shutil, shell utilities. And what I can do is if I were to, let's say, recreate this directory, let's go ahead and recreate that. Let's verify it is there. It is there. So instead of spelling it out like that, I can call the shell utility and call rmtree, remove tree, and pass to it data. And this, what it does, it recursively deletes everything under data and itself. So if I do a shift enter and go back here, you can see that that thing was deleted without me having to know, the hierarchy. And besides, what if I have, a bunch of first level folders, subfolders? This deletes everything. Everything's gone, okay? Let's go ahead and create the sample folder one more time. Let's verify it's there. It is. What I can do is I can call os.rename, and I'm going to rename sample to, let's say, final. Let's actually verify that did happen. It did. I'm going to take my OS and change directory to final. Currently, final is empty. We could take a look at the directory structure, but we know it is empty. Let's create some stuff in there. So I'm going to create coffee, and I'm going to say I want to open coffee.txt. We'll have more to say about files, reading and writing to files, but I'm going to open this for writing mode. That's what the W means. So then I'm going to take coffee, which is this handle that I just created, and I'm going to call the write method, and I'm going to write coffee time followed by tea time. And then I'm going to close the coffee file by calling the close method. Let's see if in fact that is there. If I go to final, you can see that there's my coffee text. If I open it up, you can see it says coffee time followed by tea time. Beautiful. Let me go back up to Python here. Let's go ahead and rename the file. So I'm going to say os.rename We can rename directories. We can also rename files. So coffee.txt to, let's say, t.txt. And let's double check that. And in fact, it was changed to t.txt. Okay. Let's go ahead and take a look at some file information. Get some file info. What I can do is I can call the os.stat method and pass to it the name of the file, t.txt. Well, it gives me some information, about the file, that I can see that the file size, when it was, created, modified, all that stuff is listed. Let's go ahead and pick up on a particular attribute. So picking a particular attribute, os.stat t.txt. What we can do is we can pick the particular attribute that we're after. So I can say st.size, for instance, which is 34 right here. And you can see it actually returns the value for us. Let's take a look at the modification time, os.stat t.txt, and I'm going to call st_m time for the modification time. And it gives me that modification time, which is definitely not very attractive because it's giving you the number of, I believe, milliseconds from the year 1970. So let's making the time readable for us humans. What I'm going to do is I'm going to do from datetime, which is another library, import datetime. Let's do that first, and then I'm going to print datetime.format from timestamp, one of the methods that are built in. I'm going to pass to it this thing right here. So I'm just going to copy and paste that. And it tells me that in fact it is today at 3:14 p.m. and some fraction, 3:14:07, when the last time it was modified. Again, the datetime module, wonderful module for working with datetime if that's what you want to work with. Let's go ahead and take a look at traversing a directory using walk. I can say something like print os.get current working directory, which we have seen before, and it tells me where I am. Let me actually go up a couple of levels. So os.change directory, because final doesn't have anything other than files in it. And I'm going to go up 2 levels. And let's go ahead and print os.get current working directory. So now we're sitting on desktop. Good. Let's go ahead and call walk, and we're going to pass to it our current working directory. And take a look at what we got. Not something that we expected. So this actually returns a tuple of 3 values when it's called properly. In which case we just said walk, and it just gave us basically the object. What we really need to do is to loop through the content of this object. So let's go ahead and do that. Let's create a loop since we now know about loops. Let me make some notes over here. os.walk returns a tuple of 3 values. They are dir directory path, directories, and file names. So let's go ahead and stay where we are on the desktop. Not quite sure what I have on my desktop. Let me actually see that. I don't have a whole lot on my desktop. So let me actually go to Python So I'm going to first do a change directory to Python. Let's go ahead and do that first. Sorry about that. I need to put os dot. There we are. So now I'm going to do a for directory path. These are just placeholders, directory names, and file names in os.walk os.get current working directory. Remember that just returned the object, but now we can actually loop through it. We're going to print the current path as dir path, print the directories. Let me put little spaces here as dir names, and print files as file names. I'm going to have a blank print to skip a line. If you take a look, it actually shows the current path, shows the directories that are in it. Basically, the one that we have is final, and it actually shows all the files. And notice that these are actually being returned as lists. Then it actually goes through each of those directories. So the one that's of interest to us is final. Notice there are no directories. There's only a file called t.txt, and you have these other stuff that Python internally creates for us. So very cool. You can actually walk through. It does require that you create this loop for it to be functional. So let's now go ahead and take a look at searching for a file using OSWalk, and then we'll export it. So searching for a file using OSWalk, then export. So I am going to do a for loop here for directory path, directory names, and file names in os.walk os.get current working directory. So this is going to get us all of those things. I'm going to have another for loop for f in file names. We're going to do a comparison. If f is equal to, say, t.txt, which is our file, then I'm going to first print a friendly message, file name found. I'm going to print the directory path. Remember, that's it's what's picked up from OSWalk and dumped into this during the for loop. And I'm going to have a file out, and this is going to be opening that particular file, which is well, I mean, this is going to open up a particular file on our desktop. So where is the desktop in Windows? It's under Users, Student Desktop, and I'm going to call it tcopy.txt. So it's going to be a file that we're going to create. It doesn't exist yet, of course. So we're going to create it, and we don't know what kind of a file it is. Well, we know it's a text file, but assuming that we want this to be kind of generic, we're going to do a WB for write binary, as opposed to just W, which is for writing text files. My input file is going to be opening the directory path, which is part of our OSWalk gives us, plus // plus the file name, namely t.txt. That's what the f is. And this is going to be for reading it in binary form. I'm going to create a temporary file here called data, if I can spell. And this is going to be my input files read method, which when you just call read by like that, it reads all the data. Again, we will have more on these file manipulation stuff. And then I'm going to use the output to write all the data to it. Remember, you should really close these things. So I'm going to close the output file, call the close method to close the file, and the input one, I'm going to also close it. Let's see if this works. It says the file name was found, and it dumped it. This is the directory path. Now, did it actually write it? Let's actually see if this is written to our desktop. There it is, tcopy. I'm going to double click it, and it does say what we had in it: coffee time followed by tea time. So it worked, which is beautiful. Let's take a look at printing the environmental variables. Again, if you're familiar with operating systems, this should be fairly straightforward. But we have a bunch of variables that are built in that represent various things, generally directories of some kind. And you can see there are tons of them in my Windows operating system. Mac is the same way, so is Linux. Let's see if, do I have a temp variable here somewhere? There should be a temp variable here. So, well, we'll find out. Let's go ahead and print os.environ dot get, and you can pass to it the variable that is of interest to you. And it does show that in fact there is a variable in there, and it shows you the directory here, which is great. If there wasn't anything, it would return the keyword none. So if I were to copy this just for the sake of argument and search for something called stuff, which I'm pretty sure is not there, you notice it returns none. Let's go ahead and do this print statement and look for a variable called home. And there is none in this case. It doesn't show anything. Let me try making it just be home with all lowercase, and it's also none. Okay, let's go ahead and create something inside of a temporary directory. So I'm going to create a file path. This won't create the file itself. It's important to know that. So file path would be something such as os.path.join. You call the join keyword os.environ.get, let's say the temp that we did, and append to it something called test.txt, let's say. Now remember, this doesn't actually create the file, but it modifies that particular path to have this extra. If I print the file path, you can see that we just did that. Okay, pretty cool. Let's go ahead and take a look at checking to see if a particular, say, directory exists. Check to see if directory exists. This will become handy later on when we write in code. So that exists. So we call os.path.exists and then pass to it something. So let's pass to it, oh, I don't know, temp data test.txt, let's say. And it says it's false. Now, if something does exist, let me actually copy and paste this. So if I were to do something such as, let's say, users, student, Python, final, t.txt. Okay, for some reason this came back as false also. And I'm wondering if it's because I'm using Linux format versus doing a Windows format. So let me go ahead and do a Windows format. So I'll basically take this, copy it, paste it in here. Now this is gonna be a problem, probably be false still. It gives, okay, well, give an error message. Because this backslash character has special meanings, we have to escape it. So let me go ahead and escape all of these. This is something you have to do, unfortunately, for Windows. And for some reason, it's still, oh, this file doesn't exist. It did not create that. As I said, it just creates the path, not the file itself. So you can see that if a directory does exist, we do get true, which is what I wanted. We can also check, because you can have the file name in here, we can actually check to see if something is a file or directory. Checking to see if something is a file or directory. So I can say os.path.isdir and pass to it this guy. Just copy and paste that so I don't have to type it. And it says that is true. And of course, if I do, as might expected, if I were to copy and paste this, and let's actually go into Python final. And is it called final, or did I delete that already? No, it is final. So I'm not quite sure why this gave me an error message, because I am sitting, oh, I know why. Because I need to go to the desktop first. There you go. Now, if I were to go in here and do a t-time or t.txt, notice it's a false, because now we're actually dealing with a file. Okay, so it's important to know where the locations are. Finally, let's go ahead and split a file and its extension. So I'm going to call os.path.split x for split extension. And I'm going to, what directory am I in right now? I need to know what directory I'm in. Let's actually check it out. So os.get current working directory. And let's print that. Actually, I can just do this. So I am in Python. So let me go ahead and do os.path.split extension. And I'm going to go inside the final folder. And then inside of that, I have t and txt. And notice it actually returns a tuple, where it has the file name, including its parent directory in this case, because we included that, and then the extension. Of course, if I was in the directory, then it would just return t and the txt for that matter. These are some of the tools we're going to be using later when we're dealing with files, when we're dealing with actual writing programs. I just want you to be aware of them. Thank you for being a great audience. I know this was a bit longer than usual, but I think it's worthwhile. If you're enjoying these videos, please share them with loved ones and friends. Thank you again. See you in the next one.